We'll take a look at one more example of a problem and come up with an algorithm for it, and we're going to call this problem meeting your match. The problem we're going to take a look at now involves what we call pattern matching. So the idea with this is if we're given some string of text, we're interested in trying to find specific patterns in this text. And it's a very interesting problem because there are some very nice applications to this, especially when it comes to doing stuff with DNA and mapping the human genome. If you're not familiar with DNA or the human genome, you may or may not remember from your biology classes that there are these different compounds that are part of your DNA. There are like 4 of them. No one remembers what they're called. I don't remember. But whenever we look at our DNA string, there are 4 particular ones, and we usually refer to them by the first letter of their chemical name. So we have an A, a C, a T, and a G. So if we're given that DNA string, we can look for specific sets. So like for example here, if we're given a DNA string TCAGGCTAATCGTAGG, yeah, I'm not going to try to repeat that again. But if you have that entire DNA string, we can try to probe the string to find a specific set. So maybe we're looking for something like TAATC. So that would be, let's see here, I think they're right here. Here we go. So we will look for that particular portion of the string. And this is used for looking for particular types of diseases, different types of defects. So there are some huge applications for these pattern matching problems and algorithms that we're going to be talking about. Here's the formal definition of our pattern matching problem. So we're given a text and it consists of n characters. And we'll label these as T1, T2, all the way up to Tn. So some T would be a particular character. So we have this set of characters. And then we're also given another set of characters, which we call our pattern. And there are m characters in this pattern. And in this case, m has to be less than or equal to n. Otherwise, it doesn't make any sense. And we're going to denote the pattern as P1, P2, all the way to Pm. So what our algorithm is going to do is we want to find every occurrence of our pattern within the text. So it may appear once, it may appear 3 times, it may not appear at all, but we want to know every single occurrence of where our pattern appears in our text. And so that means that the output of our algorithm is going to be location in the text where each match occurred. So we're not going to just say, okay, we found it 3 times. That's wonderful, but we need to be a little more specific. So we want to know where each occurrence is located. Now, for our purposes, the location will be the index of where the match begins. So like, for example, if we have a string of like 10 characters, that's our text, and maybe our pattern is 2 characters, and we find a match at locations 3 and 4, then we're going to say that at location 3 we had a match. So we're going to just say, where does the pattern start whenever we find an occurrence in our text? Let's take a look at an example of this problem, just so you kind of have a better idea of what we're trying to do. So let's say our text is to be or not to be, that is the question. And let's say our pattern is just 2. So what we want to do is we want to find every occurrence of 2 in this text. So when we find it, we want to output the starting position of that match. That way we know not only have we found it, but where is it located. So if you look here carefully, you can see that there are some matches. We can find the word 2 in our text. So the first output would be that we have a match starting at position 1. And that's because if we look at our text, well, there's a 2 at the very beginning. And position 1 is where the match begins, because that's the very first character of the entire text. So we would say there's a match at position 1 because there is the word 2 at the very beginning. But it also appears somewhere else because we have the not to be. So that means that we would say that the match, another match would be starting at position 14. Yes, spaces count as characters in the text. So when we look at positions, we have to consider spaces, we have to consider punctuation as well. So all that are different characters in our text. But here's where that match would be. So to be or not to be. So that T is actually at position 14 if you count it up. But basically, we're just looking at the entire string, find where it is. If we find a match, we'll go ahead and output a match. Now, if we look at the rest of the string, we don't see the word 2 anywhere else in the string, so we can say that we're done. We have found all occurrences of the word to, or I should say the pattern to, in our text. The algorithm that we're going to use consists of two parts. So the first part is that we're going to align our pattern under a specific position of the text. And then we're just going to check whether there is a match at that given position. So like initially we would put our pattern at the very beginning of our text, and we'll just check each character. Do they match? And if so, we have found a match. If not, then there isn't a match. The next part is that we would slide our pattern ahead one character position. So then we'll just do the same thing again. We'll go back to the first part. We'll check to see if there's a match at the position. If so, great. If not, whatever. Then we move on to the next part. We'll just slide the pattern over one more slot. So let me illustrate this with an example. So in our first step, we would have our text lined up, and then we would have our pattern set up as we see, where we would start at the very beginning of our text. So here we would check to see if T1 and P1 are the same character, if T2 and P2 are the same characters, and T3 and P3 are the same characters. If so, we have a match. If not, then, well, we don't have a match. The second step would then be to move the pattern over one spot over. So we would just shift our pattern over one character. So then when we go back to the first step, is we'll check now to see if T2 and P1 match, and if T3 and P2 match, and T4 and P3 would match. And we just keep repeating this for each spot in our text until we get to the end of the text. Here's the complete algorithm for solving our pattern matching problem. So the first step is we need to get N and M, so we need to know the size of the text and the size of the pattern. The next step would be to get the values for both the text and the pattern. We need to know what our text is, we need to know what our pattern is if we're going to see if the pattern exists in our text. In step 3, we're going to have a variable called K, and this is going to be the starting location for our attempted match. So we're going to initialize that to 1, because we want to start at the very beginning of our text, and we're going to keep moving over. In step 4, we're going to have a loop, and notice it's not like an official while loop, but that's okay for now. But we're going to say we're going to keep going, we're going to keep doing steps 5 through 8 until we've fallen off the end of the text. And we'll get that in just a minute, don't worry. But we're just going to keep repeating these steps until we get to the end of the text is basically what it's saying. So step 5 is we're going to attempt to match every character in the pattern beginning at position K. So we're going to check the respective characters. In step 6, we say if there's a match, then we're going to do step 7, which is print the value of K. We have a match at position K. And then at step 8, regardless of whether there's a match or not, we're going to add 1 to K. And this will take care of sliding our pattern forward by 1 position. So then that's the end of the loop, so we just keep repeating that. And once we get out of the loop, that means that we have gotten to the end of the text and we can stop. Now, you probably have some questions about this algorithm. And that's because we have several high-level statements in here. There are details that are omitted. Like, how do we know when we're at the end of the text? Or how do we actually slide the pattern forward by 1 position? We add 1 to K, but how does that actually slide our pattern? Or when we try to match every character, what's going on there? We have some details that are omitted. And for now, that's okay. It's fine that we have some of these high-level steps here that where some of the details are okay. And you might think, well, wait a minute. We said before that we need to have primitive operations. We need to make sure that the computer knows exactly what's going to happen. And that's okay. We will deal with those details later on. This is a high-level approach for handling our algorithm. So what we're really doing here is that we're separating the high-level view from the low-level view. And when we mean by a low-level view, we're talking about the implementation. How do we actually implement it? And this is what we call abstraction.